Let us discuss a question from fluid statics. This is a dam is given which has an inclined wall, and the depth perpendicular to the paper is 20 meters, and so we need to find out the total force acting on this wall. So let us consider the wall, AB. Okay, so this is 60 and you have water level till here. Okay, so obviously the pressure here will be the atmospheric pressure, and that will be, let's draw it like this, atmospheric pressure. But most of the time, remember that when we do this total pressure calculation, or basically the total force calculation, we don't we report based on the gauge pressure. So here the pressure is zero. Even though it's atmospheric pressure, but we when we do the calculation, we take the gauge pressure only. So here it is zero. Okay, zero gauge pressure, and here the pressure will be rho g h, which is acting normal to the wall, and rho g h, and h is 7. Okay, let me draw it. So, and in where in between the pressure will be rho g into the height into the depth of that point from the top level. So it will be increasing and increasing to a value of rho g h at B. So this is how the pressure will act. Pressure intensity will increase, and so it is a triangular distribution. Okay, and the total force that is acting will be the integration of this. Okay, integration of the pressure distribution and what we have drawn is the pressure diagram, and by one derivation it can be shown. When you study the total pressure and the center of pressure, you will understand that when you have a pressure diagram as like this, the volume of the pressure diagram gives the total force. Okay, the volume of the pressure diagram. But remember that what is drawn in a pressure diagram is a 3D diagram where you have the length on one side and the pressure parameter plotted on one side. So this width is rho g h, and this is AB is basically so because this is 60 and 7, so AB is the length AB, which you can find out because the vertical is 7. So sine 60 would be sine 60. This height is 7, right? So sine 60 is opposite by hypotenuse. So 7 by AB, right? 7 by AB. So remember that AB can be found out from this, and this height is rho g h. Perpendicular to the width, it is 20. So this is 20 meters. So you have a cuboid, and the volume of this cuboid is what is the total force. So how do I find out the volume? I find the area of the cross section of the pressure diagram into depth, which is 20 perpendicular to the paper. So area of cross section is half, it's a triangle, so half base into height, half AB into rho g h, right? Rho g h into 20. So ultimately, if you see, this is pressure getting multiplied with the two length units, so it's area. So by this pressure diagram, remember that when you are able to draw this pressure diagram, especially in the vertical walls and the inclined walls, this will be useful. So if you know the pressure diagram, the volume of the pressure diagram gives you the total force acting. Okay, this can be proved by integration, and there are theorems which prove this. Okay, so we'll just apply it. Half AB. AB is, we have already got 7 by sine 60 into rho g h. Rho is 10 power 3, g is 9.81, and h is total height, that is 7 into 20. So if you compute this with the help of a calculator, you get 5550.53 kilonewton. Okay, so you get kilonewton on this, and So 555.53. So we get 5550.53 kilonewton. So roughly that is 5550 kilonewton. So this is the force that is acting on this inclined wall. So remember, if you are able to draw the pressure diagram, the volume of the pressure diagram gives the total force acting on the vertical wall due to the pressure. Thank you.